until the end. And this is a good time for my clicker to fail. So let's try this manually. There we go. So I'm Chris Hyde. I'm out in Albuquerque, New Mexico. I run a small consulting company, so small that it's just me. I do BI stuff. I do DBA stuff. I'm also the group leader of the past chapter out there. We'll be having our SQL Saturday here coming up on May the 5th. I'd love to have people come out. I expect it'll be a little bit warmer out here than it was for you guys 2 weeks ago out in Cleveland. So, yeah, enjoy that. I've got my contact info here. Please reach out to me with any questions on Twitter. Mention me. Let everyone know how much you like the session. Or if you don't like it, if there's some things you think I could do better next time, well, that's what the email's for. But feel free to reach out. Excuse me, either way. So I want to have a quick word to thank Idera. I'm an Idera ace for this year, which means they sponsor me to go around to a lot of the SQL Saturdays. In the past, it's always been on my own dime, but for 2018, they're sponsoring me, so I'm very grateful for that, and I urge you guys to check out their great products. So the agenda this evening, we're going to start out with a brief warning. Then I'll give you guys a quick overview of how Python fits into SQL 2017. I'm going to cover the installation and configuration real quick. Show you guys how to get data into and out of Python from T-SQL. And then we'll jump into the real world use cases, and that's kind of the bulk of the presentation. As you can tell, I'm just getting over a cold, so you'll probably have to put up with my horrible coughing for the next 60 minutes. So I do apologize for that. But we're going to be talking about data science-y stuff, as you might expect, talking about Python. So that means that there is going to be some math. You probably expected that. I know a lot of you probably had a long day at work, so you may be kind of scared that you're going to spend the next 60 minutes seeing some math. But we'll get through it, I promise. So Python here is part of a larger part of the ecosystem called machine learning services. And this started back a couple of years ago when Microsoft acquired a company called Revolution Analytics out of New Zealand. And they have a version of the R language their version expands the open source version of R to do some things with multi-threading and spilling data to disk that the base open source just does not do very well. So it was a natural fit for them to acquire them and to bake R into the 2016 version of the software. Now in 2017, they've partnered with a company called Continuum Analytics to put their version of the Python distribution in. That's called Anaconda. And so now they had to rename it from just R services to machine learning services. So this Anaconda distribution of Python is focused specifically on data science. It comes with a good package and environment manager, and it installs with more than 100 different packages right off the bat. So there are very few packages that you'll need to go out and acquire. This Python version 3.52, and it does come with Jupyter Notebook software for sharing your code. And we'll see an example of that a little bit later. So some of the data science packages that are included, we'll look at NumPy. That gives us multi-dimensional arrays, not just a single-dimensional array that you have in base Python. It also allows us to generate some random numbers. Pandas here, that's one of the key packages. That gives us the data frame object, which is the table-like object that we'll be dealing with when we transfer data back and forth to Python. And so with that data frame object comes a number of commands to manipulate the data in the data frame. And then we'll use SciPy to do some of our scientific computing and statistical methods. Everything I'm going to show today, I'm going to focus on using computational statistics. A lot of people are out there talking about the different machine learning capabilities, and that's great. But I want to, start you guys off with just some simple statistics, stuff that you can go back to your shop and start using as soon as tomorrow, rather than wading into kind of the whole complicated machine learning ecosystem. So we'll be using a lot of SciPy. And I said we won't be focusing on machine learning. If we were, we'd probably start off with scikit-learn. That's something, if you guys are interested in going further, you'll get into. And I'm also using Matplotlib just for some simple graphics and plotting. So the installation is fairly easy. Let me blow this up a bit. So you have an option here, machine learning services in database. And you can choose either R or Python, or actually both. They play well together. Now you'll see down below there's also a machine learning server standalone. That is if maybe your shop already has a data science team and you want to leverage some of the disk filling capabilities, the extra stuff that I mentioned with RevoScales, Revolution's RevoScale R and the RevoScale Python packages, you'd use that. Everything I'm going to talk about today is the in-database integration, the sending data from T-SQL into Python and getting it back. So that's the machine learning services in database here. And this is going to give us a new service called the Launchpad service. This is the piece that interacts with the Python engine, and I'll show you a little architectural diagram here in a few slides. Now we're going to be using a stored procedure called SP-execute external scripts. That is what is going to allow us to send data into the Python engine. Now that is not turned on by default. So after our installation, we're going to have to run this simple configuration just to turn that on quickly. And then one thing I'd like to point out is that if you're setting up a server to use for data science, it's important to configure your memory appropriately. So back in the dark days when I was a DBA, I'd get a new server and I'd maybe set the max SQL memory to, say, 85% of the system and let the operating system have the rest. But the data that we're going to send to Python here, that's going to go into RAM. So if we have 100 gigs of data that we need Python to run some analysis on, well, then we have to have an extra 100 gigs of data over and above the operating system and over and above the SQL Server memory pool. So it is a different set of data. Now you will hear the term in memory, in database analysis, and I kind of give that with air quotes because it is much more efficient than say using ODBC to go from Python to the database, pull it out, but it is actually creating a separate copy. I'll explain more when we get to that architectural diagram here in a little bit. I mentioned that Anaconda comes with a package installer, and it's pretty simple. It's the syntax to add a package that doesn't come with the distribution is conda install and then the name of the package, and it will go out and grab that package and pull it down. You can also use the dash update switch to update packages as new versions come out. Now, occasionally, you'll find a package that Anaconda doesn't know about. So you'll have to use the traditional Python package manager. That's called pip. But the rest of the syntax is exactly the same. It's like I'll use the PyDataset library a little later on. Anaconda didn't know about that one, so the syntax for that was pip install PyDataset. So I hope that's pretty simple. And like I said, if you guys have any questions, just come up, turn on the microphone. I'll keep an eye out on Twitter if you don't want to disturb the rest of the class. So just send one there. Okay, so I'm going to jump into the first demo, and this is all about getting data into and out of Python from T-SQL. So I'm going to jump over to Management Studio. And let's see, hopefully that should be a pretty good size for you guys. If it's not, just go ahead and stop me. I'm going to do some configuration for something later on in the script. And then I'm pretty much contractually obligated to start this with a hello world. So we'll introduce our procedure sp execute external script, and we'll look at the first two arguments that it's going to take, the first two parameters. The first one, the language, that's pretty obvious. We've got two choices, R or Python. I'm going to talk about Python today. And then the @script, that is the Python code that we're going to run. So we'll start out with the simple hello world. Let me go ahead and run this. Let's take just a minute to get Python warmed up. Hopefully not an actual minute. Put this up here. There we go. So it's nice and simple to start out with. So let's move on to the second example. I've got a tally table in my admin database, just a sequence of numbers. I'm going to send the top 10 numbers from that tally table into Python and then get them back out. So our script is still pretty simple. It's going to take an input data set here, set it to an output data set, and kick it right back. But now we've got this input data 1 parameter, and that is a SQL query. This query is going to run, get the numbers 1 through 10, and send that into the Python interpreter as the input data. So let's go ahead and run this. And there we go, we've kicked the numbers back out from Python. Now this output data set and input data set up here, these are just defaults. If you don't like those, you can change them. So in this next query, we're going to call the input data set my query. To do that, we just have to add another parameter saying that's what we're calling our input data set. And it's exactly the same with the output data. Here we're going to call it results. And output data here, output data 1 name, results. So we've changed that piece. Let's make sure it still works. Okay, everything's good so far. Now, this query here, it's pretty simple. It's a one-liner. But let's say we get into a complicated query to bring back the data to send to Python. Well, what we might want to do then is variabilize this input data 1. So we'll say input data 1 is our input query variable, and right here we'll define our input query so we can have a nicely formatted SQL query rather than trying to fit everything onto one line. And by the same token, we could do the same thing with Python script. There we go. So I've got another variable called PyScript, and here this is just a one-liner, so again it's pretty easy, but we can pass that in here. What this has done is this has separated our business logic that's either in our query or in our Python script, and it separated it out so that we have a nice, real clean procedure call. There's quite a few people, blogging about this stuff, and nobody's really settled on a standard yet. So this is kind of the standard that I'm evangelizing. Basically, separate out all the logic. And so I could, copy and paste this query into another query window. I could copy my Python script into, Python tools for Visual Studio, into a Jupyter notebook, or whatever Python IDE I'm using, and work with it there. So I can debug outside of this procedure call. It's nice and simple. So I guess I should prove to you all that it's still working. And I should mention that these scripts, they're up on my GitHub site. I'll give you guys a link to that at the end. Also, I will zip these up with the slides and the reports that I'm going to show and shoot them over to Luis, and he can host them, and you guys can get them there. So we're going to start manipulating the data now. We're still going to send in the top 10 numbers from our tally table, but now we're going to take the standard deviation of those and send that back rather than just sending the numbers straight back. So if you guys had good eyesight, you'll have been expecting this. You'll note that we've got, a lovely error message, and I know it's really good because it's got a scroll bar. That's just my favorite kind. Now, if you're working with the R side, you'll find that the error messages are kind of cryptic. Luckily, the Python side, much easier. If we go down, we see right here, here's the error. The standard definition function here is undefined. And that's because the library that it exists in, NumPy, was never called in part of our script, or our Python script. So let's go and add that in. We'll import NumPy, and kind of the convention you'll see everywhere in data science is to abbreviate that as NP. And then we use the dot notation, so it's NP dot standard deviation here. And we get another lovely error message. Now this one is because the results should be of a pandas data frame. That's how the SPExecute external script passes the data back and forth. The standard deviation here just returns one number. So what we're going to have to do is turn that back into a pandas data frame before we can send it back as the results. So to do that, we'll have to import the pandas library. And again, the convention here is to abbreviate that as PD. So PD.dataframe will coerce that result into a data frame, and we can send it back. And there we go. That's our standard deviation. So the thing to remember is pandas data frame in, pandas data frame out. If you remember that, you can't go too far wrong. One thing I want to point out with all these error messages, when I was kind of playing around developing these scripts, they seem like they're pretty simple introductory scripts, but just decoding what the error messages were and how to deal with those, that took me about 4 hours for this whole script. So if we can take that, and I'm not sure how many of you guys made it out tonight, but if I can save each one of you 4 hours just by giving you this script, as you guys start to play with it, that's well worth my 60 minutes tonight. Okay, I'm going to skip that piece. So I'm going to look at a more interesting set of data here. And this is the IRIS data set. This is a famous data set in data science. that has the lengths and widths of petals and sepals of different species of iris. And you can use the ratio of measurements to accurately predict which species of iris it is just from the numbers. So this is kind of the data set that everyone in Data Science 101 starts with to learn how to use predictive algorithms. So this is in the PyDataset data, and we'll import that and just the iris, and we're going to kick that back out. Now this one is going to take maybe 30 seconds or so to run, just because the data library in the PyDataset package is actually quite big. I think there's about 760 different data sets, and we're actually loading them all in just so I can show you guys the iris one. That's unfortunate, but what we need to do. Now there's 30 seconds. See, every time I give it a number, it takes approximately 1.5 times as long. So maybe I just need to, next time I give this presentation, say 10 seconds, and yeah, then we'll be good. Okay, well, this is taking longer than normal. So I do want to mention here, I'll start talking about why it's going to fail, because this one is going to fail too. And the reason this is going to fail is we haven't addressed this last clause in our procedure call yet, this with result sets. This is what defines the data that's coming back. So everything we've sent back right now has just been one single column, and we're actually going to get 5 columns back from the iris data set. Now this error message is much easier. It's right in the first line, because with result sets clause specified 1 column, and the statement has 5 columns. So we just need to know that in this case, when we change our with result sets clause, we'll put our 5 different columns in here, and we're going to name them with SQL data types here. And I won't go ahead and run this. No need to take another 64 seconds. But I just wanted to show that error message and to show you how you would go about fixing that, as to add the additional columns to your result sets clause. Okay, now let's say we wanted to take this this data here that we're getting back and put it into an actual table on our system rather than just returning it as a data set. Well, we can't just do an exec this procedure into a table because this procedure could return any number of columns with different names. So the exec into just won't work. You'll get a compilation error. So you have a couple of choices. You could do an exec into a temp table, and then select from your temp table into your actual table. Or you could use open row set like we're going to do here. You put that call in the open row set command. It will make this ad hoc call and return the data, which you can then do a select into. So let's go ahead and do this. And immediately we get this error message that the open row set is blocked. This is the default for SQL Server, and it's a good idea because it's a small security hole. I'm not going to go into this. I don't really have time to cover this tonight. So I'd encourage you guys to go back to your office. If you're not a DBA, talk to your DBA, ask her why it's a security hole, buy her a cup of coffee, get her to tell you that, and then maybe buy her a beer and see if she'll actually turn it on for you, which is what I'm going to do here. So we'll allow those ad hoc distributed queries. We'll go ahead and we will run our code. And this is the 4th error message that we get. We get this unexpected indent here. And that is because in Python, white space is important. In SQL, these tabs here, these tabs here, they're meaningless. The compiler knows that it's just white space and, ignore anything. But in Python, when you have a looping mechanism, your loop is actually defined by your indents. So let's say you had a while loop. You wouldn't have a while, some condition, and then a begin and end like you would in T-SQL. You just have while, and then everything under that's in that while loop is tabbed over. So those tabs are actually meaningful. That white space is important. So we have this nice, we lose the nice part of our, compact procedure call by putting it in open row sets. But, it's still formatted here nicely so we can read it at least. But unfortunately, the Python interpreter can't understand all these tabs right here. So if we were to use the open row set, we'd have to have something ugly like this where all these tabs are, gotten rid of. So I'll go ahead and, run this. So, just a fun little gotcha with Python to deal with. Okay, are there any questions so far? All right, I'm going to take the silence as a good thing. Hopefully you guys are all still there. Just give this a few more seconds so we can see the results.
Yes, we are still here.
Good. It's kind of disconcerting giving the presentation to a silent mic, but I guess it's what we have to do. I'm just going to pretend that you guys are laughing at all my jokes. All right, coming up on our, here we go. And here is our iris data set brought back into our table. So, that's just, an introduction to how we do this stuff. And then this is what we're actually doing here. On the left, we've got our SQL Server process. That's the T-SQL code that we include the SP execute external script. That calls the Launchpad service that's running. The Launchpad service looks at that at script parameter, says, oh, it's running Python. I need to fire off the Python launcher, which opens up the Python engine. And then over here on the right, we have our BXL server. That's binary exchange language. That's the technology that allows data to pass back and forth between SQL and Python very, very efficiently. So that's how this piece all hooks together. So I've shown you guys the how. Let's talk about the most important piece, which is the why. So I'm going to talk about a couple examples from my healthcare consulting experience. And I don't want to, name any names or, shame the places that should be shamed. So instead, I'd like to introduce you guys to my fictional hospital, where all the doctors magically look like famous actors. Now, at my fictional hospital, we had a problem. We have a report. Now, I'm going to guess that a lot of you in the audience are either report writers now, or you've been a report writer in the past, or you're a DBA, but you still have to write some reports sometimes. That's probably most of you. And I'm betting that every single one of you guys that have written reports, at some point you've written a report that's caused some panic. Well, here's the report that caused panic for us. So I'm going to jump into SSRS here and pull up this charge summary. Now I could run this for the whole hospital or just primary care, but we'll run it for the whole thing. Yeah, I could limit just to cardiology or peds, for example, but we'll run it for every single department. And then I could run this just for Bones or just for Dr. McCoy, or just for Dr. Quinn Medicine Woman. Let's run it for everybody. And we'll look back here at the last 30 days of charges. So here's the report, and our hospital administrator looks at this, and they see that yesterday, Monday, our charges were way, way down. And so, they put a call into the help desk. They start panicking. Is this really a problem? Nope. Yeah, of course I wouldn't be showing you guys if it was a problem. But the reason I know that it's a problem is I've brought these charges in and done a quick analysis, and they seem to follow this traditional bell curve, what we call the normal distribution. So I know from that there's a couple of things I can take away, some things that I can infer, that we do have some variation, but it's pretty standard. There's nothing weird. We don't have multiple peaks. So it's pretty standard, it's predictable, and we can actually predict the magnitude of that variation by, here's some of that math I promised you earlier. If you guys remember this from, maybe high school, maybe College Statistics 101. But if we look in the bottom left-hand corner, we see that 95% of our data, if it's normally distributed, falls within plus or minus 2 standard deviations from the mean. Now, for our purposes, that 95%, that means that 5% falls outside of that range. And it's symmetrical, so that's 2.5% above, or 1 out of 40 days that we're above 2 standard deviations above the mean, or we're below the mean minus 2 standard deviations. So knowing that, I could get super complicated here, but knowing that, I can just go with that, plus or minus 2. I can put some control lines on the graph. This is an old manufacturing technique. I basically tell our clinic managers, okay, as long as you're falling within this range, you're good. Well, to do that, I need to use standard deviation. And how many people there want to program this formula in T-SQL? Nope, me neither. So what I'm going to do is I'm going to use the statistical tools in Python to produce a very simple report. So let's jump back into Management Studio over here. And let's see, of course, I've closed the files that I wanted to show you. So this procedure here, this is the procedure that returns the data for the report as is. So just for some context. And you see we've got the 4 different parameters that are available on the report. And it's pretty simple. We've got, our fact table here, fact charges. We've got our dimension tables that we've joined in. And we're going to sum up at the top here one of the measures from our charge table. The only other thing is we're going to filter the members of the dimension tables based on the parameters that we pass in. So this is pretty standard stuff. If you've written reports, you've probably written something like this before. Now we're still going to need this procedure on the report to return the raw data. But we're going to add a second procedure here to return the statistics about it. So you see we've got 3 of the same 4 parameters. We don't have the number of days to look back because they could run the report just for 7 days. We don't want to make any statistical assumptions just based on that small amount of data. The sample size is too small. So one thing we've done here is we've hard-coded to look at the last 180 days worth of data for our statistics. But the next part of the procedure is similar. We are summing up our measure from our fact table, and we've joined in our dimension tables. And then we're filtering the dimension tables based on the parameters we're passing in. Now we're doing one other little thing up here. You can see that we're casting the measure here as float. That's because Python doesn't deal well with our SQL decimal data type. So we're going to have to cast it to float before we send it into Python. So we're going to take this data, and I'm going to dump it into a temp table here. Now, I wouldn't dump this into a temp table in the real world. This is just for demo purposes because I want to show you guys a nice clean query, short select that we use to send the data into Python. Now, that query here, it's very simple. It's just that piece. But in actuality, what I would do is I would have, this whole, 60 or so lines of query. That would be in my input query because that's what is returning the data from SQL to go into Python. But just to make my point a little easier here, I've sent it into a temp table, so we have this nice clean query. Now, we've added a couple of things that I just want to explain. At the bottom here, you'll see that we're filtering out Saturdays and Sundays. That's because I lied to you guys a little bit. This isn't really my fictional hospital. It's really my fictional ambulatory clinic. But, that doesn't flow quite as well, and it really didn't fit on the one slide with the pictures. But in actuality, we're an ambulatory clinic, which means on Sundays here, the 18th, the 11th, so on, we're closed. We don't do any business. And on Saturdays, the 17th, the 10th, the only thing open is our urgent care. Now, we don't want to make any statistical assumptions about that for our day-to-day business. Otherwise, we'd say, hey, it's great. We're above average 100% of the... Oh, wait. So, that's a pretty easy one to catch, and we would see that as soon as we put the average line up here. This other one, is a little trickier, but just by the same token, just because we've eliminated Saturdays and Sundays, we haven't necessarily eliminated holidays. And Christmas Day last year is in our 6-month window. I think it was a Monday, if I remember correctly. So we just need to eliminate that from our data. So the points I want to make here is that when we're doing this stuff, it's not just about do we have the statistical knowledge to know that this data fits a standard bell curve, et cetera, et cetera. We also need some knowledge about the business to know that things like, we're closed these days. Let's not include those in our statistics. So we've got the data science knowledge, we've got the domain knowledge about the business, and it's this art of bringing them together that you guys will have fun developing. So we've got the data, we're going to send it into Python. So here's our Python script. Now again, we're going to use NumPy to get our statistical computations. We're going to use pandas to do the data frame. And we're going to take 4 different pieces of data, the mean, the standard deviation, the mean plus 2, and the mean minus 2. We're going to throw that into a data frame. Just the only problem is that data frame then is one column with 4 different rows. What we need it to be is one row with 4 different columns. So that results.t, that transposes that or unpivots it back. So it's one row with 4 different values. And then because we've separated out our business logic, we have a nice clean procedure call here that gives us 4 data sets in the result set. And we can then come across to our charge summary report. We have our existing charge summary, and we're going to add the charge statistics. And those statistics will allow us to put in these lines here. We use the black line for the mean, the red line for mean minus 2, and the green for mean plus 2. And so then we have a nice version of that report. I run it here for the same parameters. Come on here, little report. You can do it. Yeah, here we go. And we can see that, yeah, we were a little bit lower yesterday, but we're still within the, well-accepted, variation. So, our business users, they don't care about bell curves and distributions. They just want, give me an indication. When should I worry? When should I not worry? And that's what we've been able to achieve here just through, 6 lines of Python code. And then one other thing I want to mention before we leave this example, the green line up top, some people think, wow, well, why do you even need that? Wouldn't it be great? The more charges we have, the better. Well, actually, you can't have your cake and eat it too. That variation works both ways. So if we're way above the green line, that's the point at which I would panic. Because I would think, okay, is there a problem with the report? Is there some duplication somewhere? Did our ETL run twice or something weird like that? So that's the panic point for me. So again, you really can't have it both ways. You've got a nice range. We've got to be in here somewhere. Okay, so that's that example. Now I should mention, we can actually do this in T-SQL with the stdev function fairly easily. So yeah, again, I lied to you guys there too, but I wanted to introduce the concept of using some statistical methods with a simple example, using Python for that. And let's jump into this next example where things really aren't so simple. Now what we've got here, this is another problem we have at my fictional hospital ambulatory clinic, is some of our patients just don't show up. So I've got a no-show report here, and we'll look and see that across the whole organization, it definitely varies by our doctors. So Bones here, he's a cardiologist. Not too many people miss their cardiology appointments, so he only has a no-show rate of less than 10%. But Dr. Quinn Medicine Woman, she's a GP. Nearly 25% of her patients don't show up. So across an 8-hour workday where she sees 32 patients for 15 minutes apiece, that means she ends up being idle on average 2 hours a day. She's not making money for her. She's not making money for the organization. So, what can we do? Well, the first thought is let's just overbook an extra 8 patients a day to cover the 8 that aren't going to show up. Which sounds good, but what happens is sometimes, say, 30 out of the 32 patients don't show up. Or 30 out of the 32 do show up. You've booked an extra 8 patients, you've got 6 patients too many, 15 minutes an appointment. By the end of the day, that last person's been sitting around for 90 minutes at least. So we tried to maximize our revenue, getting more people in there. We end up minimizing the revenue because the people that are waiting 90 minutes to see the doctor, they just don't come back to our organization. So what we need to do is we need to find that level where we can overbook, without overbooking. So this is pretty common in healthcare. It's common in the hotel industry. It's common in the airline industry, but at least, unlike United Airlines, my fictional hospital, we won't be beating people up in the waiting room and dragging them out with police. We'll just make them wait. But anyway, let's find that sweet spot. Now to do that, we're going to use something called a Galton board to model this. You may have seen this in a science museum, or I think there's even a game show with this now. But how the Galton board works is you drop a ball in at the top and it hits the peg, and you've got a 50-50 chance of it going left or right. And that happens multiple times. And so this gives us a binomial distribution because there's 2 options at each peg, left or right. Now, for our purposes, we too have two options. It's not a 50-50 split, but it's the patient shows up or the patient doesn't show up. Now, Pascal figured out back in the 16th century all the the mathematics for this. That's nice and all, but I'd rather see something a little bit prettier. So I'm going to jump over to YouTube here, and hopefully I'll show you guys this video. If this doesn't work out well, I sent Luis the link, so maybe he can show you guys. Just let me know if this isn't working well for you guys. So there we go. I hope that the serious, somber tone of music didn't clash too much with the rest of the presentation so far. But so this is what a binomial distribution looks like. It looks similar to a bell curve in that it's symmetrical and centered about the mean, which is also the median. But it drops off much quicker to both sides. So we're going to need some different mathematical functions to look at that. So over here I've got what's called a Jupyter Notebook. This is an online way to share your Python code maybe with the rest of your team. It's a good way to include the code and the data and the results all in one document. As I said at the beginning, this comes built in with your Anaconda distribution, so you have access to this right from the beginning. So we're going to start out, the first cell here, we're just going to import all the things that we're going to use to run through these examples. So let me step through that. I did not want to. Okay, let's step through that. Let's load those in. Okay. Now we might want to get help. We know it's a binomial distribution. We don't necessarily know what all the functions are within that. So let's look at the online help. Now this is going to take 10 seconds or so to pop up. And there we go. So this is the list of all the methods that fall within our binomial functions. So we can use RVS to create random data that fits the profile, use the probability mass function and the cumulative distribution function to look at some of the probabilities, and that'll make more sense here in a second. And then down at the bottom, the percent point function is kind of where the magic is all going to happen. If you look at the arguments, you can actually see that they're pretty similar. We've got the n and the p in both places, and let's take a look at those in more detail. So I'm going to start off with the example using the RVS method to generate some data. Now we've said that this is like, the no show or show up, or the ball going left and right in the golfing board. It's also like tossing a fair coin, and how many heads do we get? If we call our head 1 and our tail 0, let's throw one coin, n equals 1. We'll throw it 5 times, size equal 5, and it's fair, so it's 50-50, and let's count the number of heads. And see, this time we only got 1 head and 4 tails. That's pretty simple, just change the numbers, n equals 10, we'll throw 10 coins at once. We'll do that 20 times. And you see, as we expect, lots of 5s, that's the average that we'd expect. If we do it 1,000 times, we can see just a whole bunch of 5s, and then quite a lot of 4s and 6s, and it doesn't look like any 0s or 10s. Just a handful of 1s and 9s. So you can see that probably fits that distribution graph that we saw. In fact, rather than 1,000 times, I'll throw it 10,000 times, but we'll generate a graph for it. And it's pretty easy, just a couple lines of code in Python to generate a histogram. It's still random, so it's not 100% symmetrical here, but it is what we'd expect. It's centered on the median, which is also the mode. And it falls off pretty dramatically. But if in our organization our patients only show up 50% of the time, we're not going to be in business too long. So let's see what that looks like if we change our p-value to 70%. So 70% of the time the coin shows up as a head. And we can see that skews it pretty strongly to the right. But even 70%, we saw that for Dr. McCoy, patients show up nearly 90% of the time. So let's see what that looks like for him. Now he has n equals 16. He sees 16 patients a day. And 9.6% of his patients don't show up, which means 90.4% do. Let's see what 10,000 days in his career would look like. Okay, now there we go. So what we see is about, a fifth of the time, every single one of his patients shows up. And maybe another third of the time, only one patient didn't show up. Now, what we've decided at my fictional ambulatory clinic is that it's okay to have, maybe 1 or 2 patients sitting around a little longer on 10% of our days. But on 90% of the days, we want to overbook, but not to the point where we have any extra patients. So if our threshold is 90%, only 10% of the time can we have extra patients. You see, that's not going to work for Dr. McCoy, because 20% of the time, everyone shows up. So we can see that graphically for Dr. McCoy. Let's look at it numerically. We use the probability mass function. So we'll add in this k argument. So this is, still the 16 patients, still the 9.6%. But what's the chance that exactly 15 show up? And it's, about 33%, which is what we saw on the graph. So let's use the arange function, and let's see what all his percentages look like. And that's 19.9% of the time everyone shows up. 33.8% of the time only one person doesn't show up, and so on and so forth. Now I thought this was kind of weird at first. I thought, is everybody really going to show up nearly 20% of the time? That didn't jive with what I thought I knew about our business. So I need a way to check that. And so I know a little bit of basic probability, and it's really from my misspent youth playing too much Dungeons and Dragons. but it's going to come in handy here. I know that for these discrete events, and when I say discrete event, I mean that whether or not Mr. Smith shows up for his 10 o'clock appointment, it has no bearing on whether or not Mrs. Torres shows up for her 10:30. So because those discrete events have nothing to do with each other, I can actually multiply the probability together, that 90.4% times 16 times, and I'll get my percentage. And we see that, yes, it really is that 19.9%. So when this machine learning stuff started getting baked in, a lot of people were talking about, oh, you don't really need to know any math. It's kind of a magic bullet. And I don't think that's true. I don't think that you have to be a, PhD in statistics, but you need to know some of the basics in order to be able to check your work. So if you guys only get one thing from this presentation, well, I would like it to be the script that shows you how to use SPExecute external script really well. But if you get a second thing, then I'd like it to be that you really should be playing more Dungeons and Dragons. It's really going to help your data science career. Okay, so how am I doing on time? Looks like I've been going for almost an hour. So I won't cover these range percentages too much, other than to say, where we looked before that you could say what's the exact probability, 15 out of 16. Now you can say what's the probability that 13 or fewer show up, or 13 or more. So same thing, kind of adds all those discrete percentages up for you. But we're going to get into the quantile probabilities. It's the point percentile function. I said that we had our 90% threshold. We don't want to have more patients than we have slots, more than 10% of the time, even with our overbooking. So I'm going to look at that distribution, and I'm going to pick the point 90% of the way along the curve. Well, we saw graphically that we're not going to be able to overbook. We saw from the fact that everyone's going to show up 20% of the time. So we're expecting this to say, and it does 16 out of 16. So another way is, we can't overbook for Dr. McCoy at all. So that's unfortunate, but he's still doing okay. He's not missing too much business with that 10% no-show rate. If we look at Dr. Quinn, let's look at her complete percentages. See, she sees 32 patients a day, nearly 25% don't show. Yep, that is just over, in the top left here, just over 1/100% of the time everyone shows up. And just over 1/10%, only one person doesn't show up. So in fact, we have to go down to, maybe 5, maybe 6 people, are probably not going to show up for her. So let's see what that looks like graphically. And then that looks a lot closer to some of the curves we've looked at. And so if we look back and we find the top 10%, we can see it's probably somewhere in that bar right about 27. But let's use our, point percentile function. 90% threshold, 32 visits, 75+% of the time they show up. And we see that that's 27 out of the 32. So we can pretty safely, using the statistical modeling, overbook 5 slots for Dr. Quinn. Well, that's great and all, but, our clinic managers, their eyes glazed over 20 minutes ago going through this. They just want a simple report. So let's go ahead and jump over. Let's give them what they want. So here's my overbooking report, and the first 3 parameters should look pretty familiar. And we're going to let them run it for a range of dates, and we'll even let them customize the threshold. So we've said organization-wide, 90% is good, but we'll let them, if they really want to chase more money at the expense of maybe upsetting some patients, they could set that to 75%, let's say. We'll make it dynamic for them. Now we're going to look again at the statistics, and again we're going to hard code that to 180 days. And so to pull in the data that we have, that looks similar to what we've seen before. We're going to sum up our appointments. Yeah, that's the measure in our fact table. We're going to join in our dimension table. And we're going to filter the members of the dimension tables based on the parameters we're passing in. All right, and that's all going in our first CTE here. And then we're going to figure out what our no-show rate is here with that calculation. And then we're going to, here's our select statement. And just like we saw with the example so far, it's not the no-show rate we're really concerned about, it's the show-up rate. So it's the 90% for Dr. McCoy, not 10%. And I'm going to throw that into a temp table. Again, just like with the other example, I'm only throwing this into a temp table to make the call to Python look simple for demo purposes. I wouldn't do this in production. I'd bake this whole 150 lines right into my select here. And so here I'm using the open row set, just because I could. I probably wouldn't in production. I just wanted to show you guys an example of how you would use that. So I'm selecting this into a temp table. So a very simple SQL script. Now I'm remembering to cast my threshold, my 0.90, to cast that as a float. Same thing with my 90% show rate as a float, because Python will barf on the decimals. And then my Python script is, but that's 8 lines here. We need to import NumPy and Pandas again. And then from our SciPy, this time we're going to look at the binomial function. So I need to import those methods. Just going to select my expected appointments to 0, but then I'll set that to the result of that PPF, that percent point function. And we'll send in the number of appointments that they have. So even if Dr. Quinn has 32 appointment slots, if she only has 27 patients actually scheduled, we're going to send in how many of those 27 we expect to show up. And then, that's as simple as returning back that data frame. I've thrown it into a temp table, so I'm just going to return the results from that temp table to my report. I've added one thing, this total free slots. Let's say Dr. Quinn only has 27 scheduled. We probably expect 23 of the 27 to show up based on our threshold. But we have 5 patients that, she's never scheduled at all. So we've got the 4 to overbook, the 27 minus 23. We've got the 5 that never booked in the first place, 32 minus 27. For a total of 9 slots that are still free that they need to go and book. And then I've created a nice simple report for this for our clinic managers. So we'll run it for everybody again. And we'll run it just for, let's say this week. We'll keep that 90% threshold. I needed to juice up my laptop before I got on the call with you guys. Usually it's a little bit quicker when I do this live. Okay, here we go. So here's our report. And we see here Dr. McCoy, on Monday, he only had 11 patients scheduled, but we expect all 11 to show up. There's no overbooking for him. So we still have 5 slots free that we need to get on the phone for. If we go down to Dr. Quinn, I guess that's actually today, not Monday. So we have 26 patients scheduled today. We expect 22 of them to show up. So we could overbook 4, but we still have the 6 that we never booked in the first place. So that's 10 appointments clinic managers need to get on the phone and get patients in for. So I think this example shows it's complicated statistics maybe, but I didn't need to be a full data scientist to do this. This is something that with some basic statistical knowledge, you can use the tools you're already using, like reporting services, to give a lot of value to your customers that they're not getting from anywhere else. So I wanted to leave you guys with a couple of next steps. So if you've got your cameras out, this is the slide to take the picture of. So first off, this presentation, all the slides, the Python code, the SSRS reports, it's all up on my GitHub. That's Dr. Jekyll 325. And you can go up there and, as I refine this more, as I do the presentation more, you can, follow along and see the updates. Microsoft has a really good tutorial on this. They've got a Python version here. There's also an R version, and it uses these techniques to do predictive modeling about a taxi cab company. So it's a fun tutorial to go through and start using this on your own. I'd highly recommend that. And then this last link down here, a lot of the MOOCs, the massive open online courses, are getting involved with this stuff. Coursera has one. But I think the best one right now is the edX.org one, which is in conjunction with Microsoft. And if you follow the whole program, you can even get a certificate at the end of professional certificate. You'll go through about 10 classes on the statistics, on preparing the data, on using R or Python to analyze it, and on using Power BI or Excel to present it to your users, and that's then capped off with what they call a keystone project. That's kind of a real world, class